fourth or fifth time I'm doing this talk. This is the final time, so I said, okay, I will go out with a bang. So welcome, everyone. Let's start. We're going to talk about some really, really horrible security vulnerabilities in security cameras such as this one. And I'm going to go into more details as I continue, but first I have to do the obligatory who am I? Here's another good man who made a good decision. So I have to, like, you know, do the obligatory who am I first. So my name is Amit, and my name is Amit Serper, and if you guys are like, hey, what's with the weird name? And that's because I'm originally from here, and that's Tel Aviv, Israel. And last year, I moved to the US, and I moved to Boston. And there's a really bad storm heading there right now, so I have no idea if I'm going to go back home the day after tomorrow. About 3 months ago, I was internet famous for about 2 days for doing this, and that was the NotPetya vaccination kind of thing. That was really, really terrible. The media made my life a living hell. So I said, okay, I'll just do it again. This time with bad rabbit. So that happened too a few days ago. That's actually the screenshot that shows how bad rabbit crashes when you apply my vaccine. So that was pretty cool, actually. I work as a security researcher for a really cool company called Cybereason. Hey, Trevor! I'm coming. I'm coming for you. Before Cybereason, I did some acting at a certain nation-state actor for 9 years. And as for certs, I don't have any. I actually never graduated out of high school. And I have a really, really weird hobby, other than this, obviously. I reverse engineer embedded stuff for fun. It's kind of a weird hobby, and I owe it to Zach Cutlip and DevTTYS0, which is Craig Hefner. I've been to a bunch of their talks a few years ago, and I said, oh, wow, that's such a cool thing. I need to make a habit out of it. I'm also on Twitter, so if like any of you want to contact me or like totally embarrass me right now, that's my handle, go nuts. If someone can tag Malware Unicorn and say that and tell her that I stole her look, that's actually going to be pretty funny. What's on our agenda today, other than me trying to make this thing work? We're going to do a quick device overview on that piece of shit, which is the camera that we're going to talk about. We're then going to map our attack surface on that piece of shit. That's the camera right here. We're going to do some vulnerability research, followed by exploitation, and hopefully a demo. I have a bunch of demos. So I want to tell you the story of like how this thing happened. So a while ago, and that was before I moved to the US, I went to my friend Yoav, that's also an Israeli name, and that research that I'm sharing with you guys is the work of us both. He's credited for everything in this. We did it together. So we were at his place, and we were kind of bored. It was a Saturday, and we were looking for something to hack, and he had this camera behind his desk, and like we were like, okay, let's try to hack it. So let's talk about what are we hacking actually. So this is grab a seat, Trevor. This is a cloud IP security camera, and I need all of you to remember the word cloud because that's going to come back to us. And now, when you look at this camera, when you see how, you know, if you hold it, you can see that it's really cheap and really shitty. It actually broke on the way here, so that's kind of broken right now. And we said, yeah, you know, it looks so crappy. There has to be something in there, so we had to try to hack it. So let's do a quick overview of the device. So the cloud IP camera. So what is it actually? So it's basically a computer. You know, everything is a computer, and this is running on a generic ARM architecture. It has an ARM SoC system on a chip. It's running its own brute version of Linux with BusyBox. Now, if you don't know what BusyBox is basically an environment that allows you to create a very small POSIX environment. It's basically one statically linked multi-call binary that has everything you need inside of it. So let's look at this, for example. I can zoom in because the resolution is kind of weird. So let's say you want to call some sort of a binary, right? So let's say you want to call route, which is like a regular Unix command that you can configure a routing table. So when you call route, it is actually symlinked to /bin/busybox, and busybox sees that when it's being ran, when it's being executed. It looks at you know, the argument, the argv position 0. It sees that it was called via route, and then it gives you the route functionality that's inside that statically linked binary. So let's continue. It runs a bunch of really outdated code. So like, if you look at this thing, I mean, you know, you buy it, I bought this one like a year ago, and it has code on it and a lot of libraries from like 10 years ago. And all of those things are kind of mashed together, and they were hacked together, and someone said, oh, I'm gonna try to compile it, and if it's gonna work, it's gonna be awesome. And the problem with those things is that this is never okay. If like, you compile something, and you say, I don't give a shit about security, I just want a damn thing to work, then you're gonna have a bad time, and we're gonna see that today. So remember that I said to remember the cloud thing. So this camera has something that's called a PPPP protocol. And I always say that it's like a point-to-point-to-point-to-point protocol, and the third point is probably the Chinese. And, and this was put there to circumvent like pesky NAT situations. So, you know, whoever made this camera wanted you to just plug it into your network, and he didn't want you to, you know, like mess around with port forwardings and stuff on your router. He just wanted it to plug it in and that it'll work. Now, now every camera, and I can't show it to you because the moment I lift it up, it'll break to pieces because it's a piece of shit. The bottom of it, it has a QR code, and they have an app that you scan the QR code of the camera, and then it basically builds a tunnel through the Chinese to your house, and then you can use your app to see what's going on at your house. Now it's made by a company called VStarCam, and they also they make it under their own brand, but they also sell it to other vendors, like white labeling basically, and other vendors just slap their sticker on it, and you know, they make cameras too now. Now the cool thing about VStarCam is that if you go to their website, now it's kind of blurry because of the resolution, but it says no more security vulnerability worries. It says account remote login reminder. What the fuck does that mean? Weak password prompt. We'll get back to this. Mobile phone and email address, and gesture password. I looked at the apps, I reverse engineered them, I didn't see any of that over there. Now, as I said, their apps for Android and iOS are really bad. But we're not going to talk about that. We're actually going to talk about the web server that they're running, which is the go-ahead web server. Anybody here knows that web server? Show of hands. Other than Trevor? Okay, and you guys? Okay, so we're going to talk about it. And there's also a web interface that's just a clusterfuck of elementary school level code that was mashed together and somehow managed to compile. We'll get to that too. Now, this thing is really popular. Like, I have a Shodan dork that gave me 800,000 results on Shodan. That's 800,000 root shells everywhere. And you can get those cameras in Amazon and eBay and other websites for like 30 bucks. So pro tip, if you want to secure your house, don't buy something that costs 30 bucks. I bought a lot of those from different vendors. That's like an actual photo from our office. I bought a lot of those from different vendors. You can see that a lot of them kind of look the same, except the one on the back, which is like a more sturdy model that was made to be used outside. But they are all running the same shitty code that we're going to exploit. Now, let's talk about the web server, because you know, when you're doing security research on such devices like routers and cameras and those sort of things that's now called IoT. Oh, yeah, and another thing. IoT, the Internet of Things, it is the same internet as everything else. There is no such thing as IoT, so let's stop using this really, really stupid term. So let's talk about the web server, because that's the thing that you as the user interact with the most. That's what gives you the video feed, that's what gives you the images. Okay, I'm done with this. I can't do this anymore. Sorry. Trevor will get back to you. I just executed a unicorn on stage, by the way. Can you guys still hear me? I will. Thanks, Joe Cocker. Okay, wait, something here. What's that? Why do I have two of those? Okay. Okay, I got it. Okay, so let's talk about the web server, because that's what gives you access to everything, and that's like always usually the weakest point when you're doing security research on such devices. So let's look at the features of Go Ahead Web Server. So this is text that's like the feature list from their website. Now, Go Ahead Web Server is an open source project. Most of it is open source. They have a Git repository. You can look at the code and you can like read how shitty it is. And they have something that's called a CGI handler. Now, in case you don't know what a CGI handler is, it stands for Common Gateway Interface. And that basically means that you have code that's running on this, but that code is getting input from you, the users. Now, that code could be a script, that could be a binary file, that could be whatever. But whatever it is, you control the input. Now, that's a terrible idea that was really popular in the 90s. Like, you remember when you go to websites, it was like URL/CGI-bin/something. This is that. And that is horrible. Now, as I said, this is an open source project, so the CGI is used for third parties, such as the vendor of this camera, to add more features to the product. So when those features are programmed and when they are linked with the CGI handler, once your code will be compiled with the code of the web server, the CGI functionality will be in the web server executable file. And that's important to remember, because this is what we're going to reverse engineer later. Now, back to our story. What we were looking for was code execution, remote code execution. We wanted to point our fingers at an IP address that has this and get a root shell. But we had one problem. We didn't have the firmware. Now, usually, again, when I did a lot of security research on those kind of things, and usually what you do is you go to the vendor's website, you download the firmware, you unpack it, and then you start reverse engineering. But in that case, this thing is so generic that we didn't know who makes it, because it's such a generic Chinese product. And we can't go to like genericchinesevendor.com because we don't know who the vendor is. So you know what that means? We literally took a hammer. That's the camera that we were working on back at the time. So we actually took a hammer and we tore it apart. And you can see here that it has a board. This is the board right here. Ah, my God, that was dangerous. It has a board right here. The resolution is super weird. I have no idea why. But what we did is we found the UART headers on that board. Now, if you don't know what a UART, if you don't know what UART is, it's basically a serial interface that you connect to, and it basically gives you access as if you had a monitor and a keyboard connected directly to the board. So if everything works out, usually you get a root shell, but you have to do this ugliness. Now, this is actually what we did. So we used a bus pirate. That's the red board over there. And we found the headers, and we connected and soldered some wires, and we booted the thing. And after we guessed all the properties, and that took us a while, we plugged it in, and we saw a bootloader, and eventually we had a root shell. Now, while this is a root shell and this is really cool, this is still not remote code execution. This is just fucking around with a hammer. So now what? So now we need to get the actual files from this thing, from the flash memory that's here on the device, because we wanna reverse engineer it. We wanna look at it and we wanna see what's in there. So actually, what we did is we transferred all of the MTD blocks, /dev/MTD blocks, to a computer using nothing but DD and netgat, and that was super easy because now we had a shell on the camera. So we just executed this command. We piped it to netcat. we had another machine listening on that IP address and port, and it basically just wrote everything from the flash, piped it to Netcat, and we had a file on the other side that has all the firmware. So now, we could use traditional tools such as binwalk, and if you don't know what binwalk is, I'll talk about it in a second. We can use binwalk to actually extract all the files and look at them. I'm done with this too. We'll get back to it, Trevor, don't worry. You're in heaven now. Again, the resolution is really weird, but what we see here basically is we have all of the offsets and what's in those offsets. So that it has a bunch of LZMA compressed data up there. Again, it's impossible to read in this resolution, but that's like the kernel, and after that, that's actually the disk partition. So now, when we have access to the actual files, we know that this device actually runs a kernel from 2008. And if you're into Linux, you know that this version was probably like the worst. It has like 60 different kernel exploits. And that's a kernel from 2008 running on a product that was purchased like last year. So that's already bad. We know that it's running go-ahead web server. I already talked about it. And we know that the source code is available, so it actually saves us a lot of work because we don't need to use IDA Pro. We could just go and read the code. It has a lot of poorly written looking code, along with a lot of really old libraries and other kind of software. It's like, it's a mess, and you'll see it. And the password for the web administration is stored in clear text in a file that's called system.ini in the web root directory. Now, you can't ask for that file because it's password protected. But all of this says that something has to be vulnerable there. So let's take a break from the story for a second and talk about user-controlled strings, or input, or whatever you want to call it. So when the user, which is you, when you're interacting, when you're communicating with software, with a piece of code, you are actually sending input to it. Now, this input that you are sending is controlled by you, the user. Now, the software then takes this input that was given by you and applies some sort of logic, some sort of, that's basically the code that's running there. So it gets input from you, and then it applies the logic on it. Now, if something in that code is vulnerable, if you can subvert the execution path, or if you can use your input to fuck up with whatever that's running here, then it means that you're a good hacker. Next. Okay. Now, let's start mapping our attack vectors. So first of all, we need to understand where is or are there any user-controlled strings. And once we find those places, we need to understand if the code that handles those, if the code that handles the input from the user, we need to understand if it's vulnerable. And if it is vulnerable, we need to understand how hard is it to exploit it. So let's try logging into the admin panel, because that's where all the goodness is. So we just visit that URL. That's like the IP that the camera had on the network. The port is running on, the web server is listening on port 81. And we are immediately hit with a password box, because you need to authenticate in order to get into the admin panel, right? Now, okay. So, such anticlimactic. So the first stop is to actually analyze the login process. What happens when you log in? So let's talk about that password authentication box that we just saw. So we looked at it, and it didn't appear to be easily exploitable. I mean, there was a buffer overflow there. We actually managed to crash the web server after we supplied a really, really long username. But buffer overflows, they require writing shellcodes and debugging, and we were lazy, and I don't want to do that. So what happens there? It just compares the input that you're giving it, basically the username and password. It just compares it to what's in system.ini. That's the file I told you about earlier. And if it matches, you're authenticated. Now, as I said, buffer overflows, not cool on a Saturday. No. So let's think about it again for a moment, right? So we need to understand what is the first point of contact of a user-controlled string with the web server. And that is the web request itself. Now look at that GIF. Isn't it nice? Yeah, things were simple back then. So let's talk about HTTP requests. So this is a really, really basic example of how an HTTP request looks like, right? We have the action that we want to do, that's in red, that's get. We want to get a file we're requesting. We then have the path of the file that we're requesting, that's in green, that's /index.asp. Now slash is really important because when you're using HTTP, you have to start with a slash. You have to start from the root and build your URL from there. And then in the end, in black, we have HTTP/1.1. That's the protocol that we're using. Now, if everything checks out, if all the permissions check out, if everything is OK, the server then responds with something that's called an HTTP response 200 OK reply. And that packet, that HTTP packet that you're getting, or actually a series of packets, will contain the data that you've asked for. And again, that's all going to happen if everything checks out, if the page exists, if the permissions are OK, etc. So let's go, and as I said, this is open source, so we can actually look for that code and find it. So we actually went 10 years back in Git because we discovered, right at that moment, we realized that while this thing, this thing, as I said, it runs go-ahead web server. It was running a version from like 10 or 12 years ago. So we had to go way, 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 way back in the Git repository to find that vulnerable code. So we found that function webs-getPort, and we took it from there because we saw that, like you can see on the top, it takes the web request apart and start figuring out which is which and where is where in the request. And then we saw that. And that's where things start to get stupid. So as you can see, those three red arrows, they point for the most alarming thing in this whole research. So as I said, there are several types of requests, right? You have GET, you have POST, you have HEAD, whatever. Now, again, HTTP is a protocol. It has, when you are working with it, you have to work by the protocol. And if you send a request that's malformed, or if you send something that doesn't conform with the HTTP standard, you'll get an error. And that error is called 400 bad request. You can see it right here. So basically what this code says, it says, if the user sends an HTTP request that is not a GET, a POST, or a HEAD request, you need to send him back a 400 error, bad HTTP request. But the thing is that you can do whatever you want. You can send whatever request you want. You can send the content of the request can be whatever you want as long as it's a GET, a POST, or a HEAD request, right? So, recap. An HTTP request is only considered legit if there is a slash at the beginning of it, because we have to start from slash. There is no real exception handling of web requests. You will only get a 400 error if the request that you sent is not a POST, a GET, or a HEAD request. Things are about to get stupid. So, if we'll send a request like this, and I actually, live demo number 1, this is so weird with that resolution. So what I'm going to do, I'm going to connect to the web request, to the web server, right? And I'm going to send a normal request. Get system.ini HTTP on. And as you can see, we get an error unauthorized, right? Now, we got that error because we were trying to ask for the file that has the password. Now that file is protected by the password. We just requested, we didn't do any authentication, so we got an error. But, as I said, the request can contain anything as long as it's a GET request or a POST or a HEAD request. So, live demo number 1, I'm going to clear that. I'm going to do that again, and this time I'm going to do get system.ini, no slash, right? No slash. Every other web server should give me an error. But if I'll do this, I'm going to get the file with the password. It has a bunch of binary crap in it. That's the question marks. Ignore it. But you can see under the nist.gov, if you look one line below it, you'll see admin and then ZAQ QSWCDE. Admin is the username. Hard-coded, can't change it. And what follows it is the password. Now remember the weak password thing that they said, that there's a warning if you set a weak password, that they said in their banner where there's no security vulnerability worries? So I really wanted to impress all of you, and I wanted to set a really strong password with a whole bunch of numbers and characters in uppercase and lowercase. Like I wanted to show you how useless it is. But every time I tried to set a strong password, I got an error. And I couldn't understand why. So I started reverse engineering the server and debugging it, and then I saw that the developers made a mistake. This is really bad. They used an or instead of an end. So a password can only be all lowercase, all uppercase, or all numbers. No more security vulnerability worries. So that was live demo number 1. That's my backup, but it worked. Okay, so demo number 1. And as we saw, we got the file with the password. Now, you're all saying, well, great. So you have the password to the camera, and you can like look at whatever it is, you look at whatever it is it's filming, it's recording it. You could look into someone's living room. Wow. This is not news. This was like the first episode in CSI Cyber. So what we did after that, we started like going through the admin panel. Now, as you can see, beautiful design, breathtaking user experience. Now, whenever I do those sort of things, I'm a one-trick pony. So what I always do is, whenever I see those boxes that get input, what I always do is I just type ;reboot in them, and I hit submit. And if the device reboots, it means that we have code execution as root. Super simple. So I did that, and the device rebooted. We're like, shit. Now that means that someone is calling system with user input. Bad idea. Now if you don't know what system is, this is a standard C call that's in stdlib.h. What you basically do is you call a function that's called system, and you pass the argument to it. The argument is the command you want to execute. The command will then be executed as a child process of the process that has this. So in that case, when I wrote reboot and submitted it, what happened is the web server executed reboot as a child process of its own, and then the camera rebooted. So that means also that the web server is running as root because it rebooted the device. Never run anything that's facing the internet as root. That's a bad idea, and you're going to have a bad time. Now, I always say this because I've done this specific talk several times and other talks about like Internet of Shit security. I see this everywhere. Everywhere. I've worked on more than, I think about like 300 or 400 devices. And majority of them, like 75% did this. Don't ever do this. This is a bad idea. Now, that is actually called a command injection vulnerability. And that means that the input that's being provided by the user, that input that goes to the CGI handler that we talked about, is not being sanitized, right? That means that the input is being sprintf directly into a buffer that the system is being called with that buffer. That's being passed directly to system. No one cares about what's going on in the input because it just compiles, so it's okay. And no one is looking to see if you have those characters in there, the semicolon, the pipe, end, and backtick. There are other variations, but these are like the usual ones, the usual suspects. So semicolon means run this command, like you do semicolon reboot. So it means run reboot once you've finished running the command you ran before. Pipe means take the output of one program and pipe it into another program. So all of those are tricks that you can use to do command injections. And now it's IDA Pro time. I mean, I said, okay, I have to see if that is what I think it is because, it rebooted, but I wanted to be sure. So I looked at it in IDA Pro, and if you remember that page, I'll go back. That page it's called the mail sending page. So this camera has a feature, and it's constantly looking at your house or whatever you put it, And if it detects any motion, any movement, it can send you an email. Now, when it sends that email, it actually looks like this. There's a string that you can tell it, okay, send me an email that has a string in it. I don't know, someone is breaking into your house. And pipe it into another process that's called MailX. And there's a bunch of arguments here, -a, whatever that means, percentages. And again, another percentage S's all over the place. We inject our command into those places because no one sanitizes the input, right? So that means that we have remote code execution. So we're almost at demo time. Now, when I did this in DerbyCon, Trevor, you probably remember that, when you surprised me with this disgusting, what was it, Zima?
Oh, Zima, that's right.
Yeah, that was fun.
Warm Zima.
Warm Zima, hot Zima. I said, because I did this talk before and everybody said, well, you know, it's not really impressive because the camera has to have all of its ports exposed to the internet, and this is like a nice POC, but in usual cases, it doesn't happen. Only like one port is forwarded to the camera, and if you want to pop a shell, if it's not a reverse shell, and I'm not doing a reverse shell in that case, you have to have a port open that's forwarded into the shell we want to connect. And people told me when I did my demo, it's like, oh, it's not really impressive because your camera is connected directly to your computer. So, you know, you have all the ports. And I said, okay, challenge accepted. So I built this setup. And this setup is actually, we have the attack machine, which is my laptop. And we have a router. And I have a shitty router here. And our attack machine is connected to the router on the WAN side, right? To simulate that we are like coming from the internet. The router has the camera connected to it on the LAN side, and it has a Raspberry Pi. And I'm going to use the Raspberry Pi to basically simulate another machine on the network, and I'm going to show you how I'm going to pivot from the camera to that machine by forwarding ports, by actually taking advantage of the router. Now, that works in almost any case if you have UPnP turned on. Now, the reason this diagram is kind of ugly, and it looks like this, is because I'm really bad at doing graphic stuff, and I didn't have anyone to help me. And another thing is, I mean, I'm a foreigner. I moved to the US last year, and when the block that says attack machine was originally here, and then I realized that it looks like a dick. And after a year in the US, I learned that this is offensive to some people. So I said, okay, don't want to cause any shit, right? So demo time. So what I'm actually going to do now is I wrote some exploit code that does everything I show you now, but instead of executing a semicolon reboot, I'm going to execute semicolon telnet D because the camera has on its image, like the kind folks that you know created the image that's running on that camera, they were kind enough to include all sorts of really, really nice tools for security researchers, such as Netcat and DD that we used before to extract the data from the camera, and they also included a telnet server. How convenient. I don't need to write shellcode. Now, what this command does is running telnet D, and -p says what port you want to use. So I'm going to say just use port 4444. Now, the problem is that if you ever use telnet, you know that when you're connecting to telnet, it asks you for your username and password. Now, I don't know what the username is. I mean, I know that the username is root, but I don't know what the password is because I had nothing to do with the image. I have no idea what's in /etc/passwd. Like, what's in there? I don't know what the password is. But telnet D has a really cool flag that's called -l. And -l means, what program do you want me to run after a connection has been established? So I'm saying just run binsh and give me a shell. So that's my trick. So what I'm also going to show you is how I'm going to take advantage of UPnP. So let's talk about that after I'll show you this. So as I said, I wrote some exploit code, and it's here. It's called campone. So I have it saved here. Okay. So what I'm doing now is I'm sending that broken packet without the slash. And I actually had to write that myself because all the Python modules that are doing HTTP requests such as request or URL lib or whatever, they can't send this packet because this packet doesn't conform with the HTTP standard. So I'm actually using raw sockets to create the request that sending a GET request without the slash. So first what happens is it asks for system.ini to extract the password from it. So it did it here. And then it opens a root shell using the telnet trick I showed you. Now, as I said, this is connected. This is like the internet. So now there's a root shell waiting for me on port 4444. But if I'll connect to the camera on port 4444, it's not going to work. It's not going to connect because this port isn't forwarded on the router to the camera. But, as I said, we have UPnP enabled on the router. Most of you probably have UPnP enabled on your router at home. I really hope that most of you are going to turn UPnP off after you'll see this. So if you don't know what UPnP is, or to be specific, UPnP IGD, Internet Gateway Device, and that's the RFC if you really want to read it. UPnP is a protocol that basically allows software to connect to the UPnP API that's on your router and ask it to forward ports from the WAN side to the LAN side. So for example, if you use Skype, Skype was, I think, one of the first programs that used UPnP. So like, you know, it needs to forward ports because if you're behind a NAT router, your computer isn't accessible from the internet. So Skype, for example, sends a request to the router and say, hey router, I need you to forward me port 1111 to this IP address on the LAN side to port 1111 TCP. Now, that seemed to be a good idea back at the time. Like JavaScript or Brexit or a lot of other horrible ideas. Now, these cameras have a UPnP client on them. The server, as I said, is running on the router, but the client is running on the camera. And because I know it because I reverse engineered the code, and I saw that at some point it calls a file called UPnPC static and passes a bunch of arguments to it. So this is what UPnP static looks like on the camera. So you can see, I can just ask it, I can just call it and I say -a add IP space port space external port space protocol. Basically, I can open any port I want on your network and redirect it to anything that you have on your network, only because you use a shitty camera that you got off of Amazon. So let me show you that. So what I did is I wrote another exploit, and I called it Campone UPnP. And basically, I can just forward that port. I'm going to say, I just realized that I forgot what's the internal IP of the camera inside the network. I'm gonna see if it's this. I totally forgot what the IP of the camera inside the network is. So if that demo is going to fail, it's not because of the demo god, it's because I'm an idiot. That's like the only thing I didn't test. So we're waiting for that to run. Now, while it's running, you know what, I won't waste your time with waiting. I'll get back to it in a second. I want to talk to you about some interesting facts. So the slash vulnerability, so we went and disclosed it and did responsible disclosure, which came back to bite us back in the ass. And it was actually discovered by this guy, Luigi Oriyama, on a printer that was using that server back in 2004. So what we thought was a 0-day was actually like a 4,745-day exploit, which again demonstrates how shitty that thing is. So we got 2 CVEs for that vulnerability. Those are the CVEs. And then, any of you heard about the Persirai botnet? It's like another botnet like Mirai. So they actually used our exploits because we responsibly disclosed them. So this is like not our fault. Don't deport me. Let's see if it finished. Okay, let's try that. Yes! And as you can see, we now have a root shell. I can show you, I'll do ID. As you can see, I'm UID 0, I'm root. That's code execution. That works on every router that has UPnP turned on. Every router, doesn't matter which vendor. Even like an expensive Cisco. So kill your UPnP that's running on your router. Some routers, like cheap routers, such as this thing I bought here, you can see it. It's a router that cost me 10 bucks. I got it for my demo at DerbyCon. As I said, I have like 5 minutes. So I can actually give you a bonus, because my hobby is to break into cheap shit. So I can actually show you real quick how shitty those things are. I have another vulnerability that I found on that router. So that router always listens on port 8080 for its administration panel on the internet side. You can't turn it off. Now, if you send this HTTP request with no authentication, you'll get all of the configuration, including like the Wi-Fi password, the whatever, like everything is in there. So like, those things are really crappy, and it's like clear text. Now, remember I told you about the Raspberry Pi? So I want to show you something. So I showed you how I opened the port and forwarded to this camera. But I also have a Raspberry Pi that I hope it's, yes, it seems to be working. I also have a Raspberry Pi on a network that's simulating another machine, right? And that Raspberry Pi is running a web server. And I want to show you. Yeah, I want to show you. This is really difficult. If I'll try to connect on this port, oh, I already ran it. Shit. So, anyways, it doesn't matter. I just saved you like 3 minutes. So what happened is I used the same exploit. To forward a port so I connected from the internet to the camera, executed the UPnP client that went to the router and said, hey, I want you to forward this port 10,000 to the IP address of the Raspberry Pi, which is like completely unrelated to this whole thing. So that means that I can use a shitty device on your network to basically pwn your entire network and just do whatever I want with it. Some shout outs, because I'm like done. My friends from Cybereason, some of them are here. Zach Cutlip and Craig Hefner, like I owe these people pretty much my career. Like they're really awesome, and you know, if you know Vis, he's really cool. He pushed me to do a bunch of talks and conferences. Patrick Wardle, he's a really cool guy, does a lot of, he's a good friend of mine, does a lot of security research tools for Macs, which is also a thing I do. And he also, like, I always talk to him, and like, those people, and Jonathan Levin wrote like the best book on macOS security. Like those people are like the people I come to talk to and come to bounce ideas off with. And that's what makes this community great in this industry. Like, you know, if you take out all the drama from it, like especially if you're like on Twitter, it's like those kind of things that make this thing cool, because like I'm getting paid to do what I like, and this is awesome. And I think all of us are doing it, and it's because of people like this, an atmosphere like this in the community. So don't be assholes to each other, like be nice. Thank you. I think we have like 2 minutes for questions if anyone wants to ask something. Very good. Oh, yeah. The question was, and it's a very good question. The question was, well, I showed how I forwarded a port to the Raspberry Pi, but in order to forward that port, I needed to know the IP address of that inside the network. So there isn't, and you know, if there's any way I can scan or fuzz those IP addresses, there isn't really an easy way. What I usually do is I just forward a whole bunch of ports, like, you know, port 80, port 140, like 145, like default ports. I just forward all of them, and then I start like scanning it from the outside. Any other questions? Yeah.
Was it possible to do a reverse shell, like command execution?
Yeah. Yes. so the question was if it was possible to do a reverse shell. It was possible. It's just not such a cool, like this is a cooler demo. Another questions?
Who's the router vendor?
The router vendor?
Yeah.
Tenda. $10, pristine.
$10.
Are those V-Star cams, are they the same people that make the crappy Foss cam stuff, or is that different?
So really good question. So the question is if the crappy V-Star cam make Foss cam. So actually what I found out when I bought all of those cameras, so Foss cam is a completely different company, but their low-end stuff is that. Their higher-end stuff, which is also really shitty, is running different code. But the lower-end stuff, I think they outsourced it from them. Because it's like, it works. I have a Foss, and one of those cameras that I showed earlier, one of them was a Foss cam from, and it looked like this.
Did you end up finding a camera that you would feel safe about recommending to someone?
That's a problem, because I don't think, I mean, I always, like, people ask me, I say, I don't know, get a Nest or something. But, I mean, no one found something on Nest cams yet. So, like, it's a problem, you know? I think I'm done. If anyone wants to ask me more questions, we can do it, like, after I clear all of that mess from here. Thank you, guys. Thank you very much.